Unit 2, Lesson 1, adding positive fractions and mixed numbers. Again, here you can see our standard of what we're going to add, subtract, multiply, and divide positive fractions. It's fractions and mixed numbers. When we talk about that, we'll zoom in here on this slide over here. You can see, again, when we have fractions, we need to have that common denominator. So the bottom number's got to be the same. So when we have them like this, it's very nice. You keep that bottom number the same. You keep it common. We add across the top. And then once we have that, we always check to make sure in class, can we simplify 3/5? Are they both even? Do they end in 2, 4, 6, 8, or 0? Nope, can't divide by 2. 3 goes into 3, but not to 5. So we're done. Again, when adding fractions, they need to have the same bottom number, a common denominator. They have to be in the same size pieces, and then you just keep it common. That's that phrase, common denominator. And then across the top, since the bottom numbers are the same, since we have a common denominator, add across the top. And if you can simplify, you need to, because IXL will accept this, but I will not. In math class, it needs to be simplified. Since they both end in 2, 4, 6, 8, or 0, we'll divide them both, the top and the bottom, by 2. The same number, and so we get our final answer in simplest form. That is what we need. So when we look at this guy, notice again right away, we're not going to add unless the bottom numbers are the same. They have to have that common denominator. So from here, since they're different, we have to find what that common denominator is going to be. A couple of different ways to do it. You can always just take the two numbers and multiply them. 4 times 5, well, that gets us 20. But in doing so then, we need to make sure that we have our common denominator, but 4 does not magically become 20. We took 4 times something to make 20. 4 times 5 gave us 20, so now you have to be nice. You must share and multiply the top by 5 as well. From there then, you go to the next fraction, and it's not 3/5 anymore. We took the 5 times 4 to make the 20. So if you multiply the bottom by 4, multiply the top by 4 as well. And that's where we get this 12 on the top. Let's zoom on in so we can see that nicely. From there, now we got that common denominator, so you keep that bottom number common, the same. You don't add the bottom, but we're going to add across the top. 5 plus 12 gets us 17. And again, although IXL usually accepts this, we're going to want to make sure that we're always checking, are they both even? Do they both end in 2, 4, 6, 8, or 0? Nope, then we can't divide by 2. But don't forget to try 3. That's one we often forget. Can 3 go into 17? Nope. 4's even, so don't need to check that. 5 goes into 20, but not 17, and you just keep checking to make sure nothing can go in there. 7 can't, 9 can't, 11, so on and so forth. Now again, your next example, you just need a common denominator. So if you take 9 times 3 and you make 27, that'll work. You could use 36 as a common denominator. There's so many different choices. However, I'd like to again show you a little math hack or a little something that's helpful. I'd like to be efficient and do as least work possible. So it sounds silly, but which number between 9 and 3, which number is smaller, 9 or 3? Since the 3 is smaller, can we take 3 times something to make 9? Well, yeah. So since we can, let's do that. Because then, I only need to change one fraction. Because 3 times 3 gave me 9. Take the top times 3. Now I have 3/9. That's enough work for me, but of course as your teacher, I'm going to copy this down so you can see it all on one line. But otherwise you can just, again, keep that common denominator common. Keep it the same. And then add across the top. Now notice again, when we've got these, they're not even. You can't divide them both by 2. They're not ending in 2, 4, 6, 8, or 0, but be very careful. Don't forget to try the number 3, because 3 can go into both of these numbers. So in math class, we do need this to be 2/3 when we're all said and done. And that's what we're going to see more of. We're going to have all these uncommon or unlike denominators. We're going to have to build like denominators, common denominators first, and then add. We're not going to really have these guys where we just get to add and be done. So when you go to the next slide, again, 12, 24, 36, 60, 600, any common denominator you want is fine, but in math class you have to simplify it. So again, do we have common denominators? Nope. So then, to practice, let's see, which one's bigger, 6 or 2? Since 6 is bigger, can we take 2 times something to make this larger number? Well, yes. So then let's do that. Let's be efficient and do all the work we need, but with as little work as possible. So again, this is enough. If you want to tell me the answer is 8/6, that's all I need. As your math teacher, you're going to see that one. I'll write it down here again. So I got that common denominator, and then I just add across the top. Now, there's a couple ways we can do this. Since they're both even, I like cutting it in half right away. Because usually I can halve things pretty quickly, because 8 divided by 2, 8 cut in half is 4. 6 cut in half gets us 3. Now again, IXL may or may not accept that. However, this is called an improper fraction. So I won't accept this. This is an improper because the top number is bigger than the bottom. So then we ask ourselves, how many times can the denominator, the bottom number, go in the top? 3 goes into 4, 1 time. We take that 1, that whole number times the bottom, that's where we get that 3, and subtract away. 1 times 3 is 3. Take that from the top, and we're left with 1 and 1/3. You keep that denominator, the same here. Once you've simplified it, off we go. Can you simplify this guy? Nope. So there's our answer. Again, we're adding fractions, and we're adding with mixed numbers. However, since we're adding with mixed numbers, let's add the fractions, and then we'll add the whole numbers together. So, but before we can add fractions, we need a common denominator. So when looking at that, then again, when we don't have it, it's going to be most of the time today, when we don't have it, you could choose 16, you could choose 32, 24, any of those work, but again, they're not the same number. Which one's the smaller number? Since 4 is smaller, can you take 4 times something to make 8? Sweet, and off we go. Since 4 times 2 is 8, take the top times 2 as well. Again, this is enough work for me. As your math teacher, I'm going to write it down again so we can all see it on one line. But like I said, now we're going to add the fractions. But in doing so, you keep the common denominator and you add across the top. And then since we have mixed numbers, now I want to add the whole numbers. So I usually draw arrows to those. So there's nothing here, plus 1. So again, that's 1 and 7/8. I cannot simplify the 7 over 8. So I box it on up. There are other strategies as well for solving these. You can make them improper, but that's just a little bit extra work, and I'm trying to help us to be efficient. So again, when they're mixed numbers, let's first focus on the fractions. We're going to add the fractions, but no, you cannot just add straight across. We need a common denominator. If you know it's 12, awesome. Then make them 12 and off you go. If you're not sure what it is, well, just like we did before, can you take 3 times something to make 4? Nope. So 4 times 2 gets us 8. Can we take 3 times something to make 8? Nope. So what's 4 times 3? Normally I do this with my hand so you can see it out front, but since I'm recording it, I'll write it here. 4 times 3 is 12, and you can already see it, but can we take 3 times something to make 12? Yes. So then that's going to be our common denominator. But don't forget, when you take 3 times 4 to make 12, multiply the top by 4 as well, because 1/3 of a pizza is not the same as 1/12. But 1/3 of a pizza is the same as 4/12 of a pizza. Same thing. 3/4 of a pizza is not the same as 3/12. Make sure when you take and multiply the bottom by 3, you multiply the top by 3 as well. So from here, again, now I'm going to add across the top. That gets me my 13 twelfths. And then from there, again, I'll invite you just to draw an arrow to it, but we need to add these whole numbers. So 2 plus 1 gets me 3. 3 and 13 twelfths may or may not be accepted by IXL, but it will not be accepted by me. Again, we call this type of fraction improper because the numerator is larger than the denominator. The top's bigger than the bottom. So in that case, we need to see how many times the denominator, how many times the number on bottom can go into the number on top. The numerator. 12 goes into 13 one time. So I'm going to put a 1 here so I don't forget. 1 times 12, take that away from the top. That's why I've got 1 on the top. That number on the bottom is going to stay there. But now I got to be careful because now I don't have 3 anymore. I made another whole number. So I need to take and add that 1 to the 3 and get 4 and 1/12. Oftentimes, the mistakes come in when we have to start simplifying fractions or if we forget to do that. But notice again, we talk about fractions. That's our standard, being able to add and subtract, multiply and divide positive fractions. So again, for you and I right now, focusing on adding positive fractions and being able to do that correctly and efficiently. Go ahead and turn the page. So here in extra practice, I'm not going to do the first one again. Build a common denominator, simplify. I want to do these other two here because they are unique. Again, on number 2, again, this is the parenthesis, or 2. So if you need to do that, so you know that that's number 2, and this is the problem, you can. Looking at the fractions, this one's weird, but that's okay. Let's just add. Do we have a common denominator? Oh, sweet, we do. Get 21 thirds, again, adding the top, keeping the bottom the same, and then I'm just going to add these whole numbers out front. How many times does 3 go into 21? Wow, that's quite a few times. 3 goes in there 7 times, and 7 times 3 gives me 21, so then I have 0 left over. Now, don't forget to add these two up here. So I made 7 new sets of whole, and then we add that 6 to it. Now I will accept 13 and 0 thirds, but that's just the same as 13. So sometimes our answer can turn out to be just a complete whole number with no fraction. Speaking of a whole number, on number 3, any whole number is written as a fraction. 2 as a fraction is 2 over 1. And so from there, now we add our fractions. Oh, wait. In order to add fractions, what do we need? That's right, a common denominator. So make it. If you can change one of the fractions, and only one, do that. Makes life more efficient. Again, this is enough work for me. But as your math teacher, I'm going to rewrite it so you can see it. A parentheses. Yep, there's nothing in there. There's no other parentheses, no exponents, no multiplying or dividing, no adding or subtracting. That's just there kind of to hold that as a fraction. Now that we have that common denominator, we add across the top, and you keep the common denominator the same. That's why that phrase common is there. So again, when we talk about common, the common denominator stays common. Everybody say common. I don't know if you said it, but I hope you did. But from there, again, that's why this common denominator, we keep it because it's common. It's the same on the bottom. Add across the top. Bottom stays the same. IXL may or may not accept this. I will not. 2 goes into 11. How many times without going over? When you get that 5, because 5 times 2 is 10, we're going to take those 10 away from the 11. So we can see we've got 1 left over out of the 2. That bottom number carries down. So 11 halves, 11 over 2 is the same as 5 and 1 half. Again, kind of a spoiler alert today as we look at real life problems. We talk about it. Today we're talking about adding fractions. So when you mow a third of the lawn and your sister mows 3/7 of the lawn, what's the fraction of the lawn is mowed. In total, what part or what's the sum, all these different phrases that we might be using. But here, what part is mowed, we need to combine that. So don't make the answer magically appear. Show me some work. So again, you don't have to circle it on up. It's just a helpful tool or strategy for word problems. So now I can see those guys. I need to add them. You may multiply the numbers on the bottom right away to find a common denominator, or again, 3 is the smaller number. Can you take 3 times something to make 7? No. So then what's 7 times 2? 7 times 2 is 14. Can you take 3 times something to make 14? Nope. So what's 7 times 3? 7 times 3 gets us our 21. Can you take 3 times something to make 21? Yes. So that's why our common denominator is going to be 21, or at least one of them, one of the many common denominators will be. Again, show me the work. Take the bottom and the top times 7. Don't just put the times 7 on the bottom, because 1/3 of a pizza is not the same as 1/20th. And the same thing here. Take that 7 times 3, put times 3 by the top. So you remember you got to take the top and the bottom times that same number to change it into a different fraction. It's an equivalent fraction because 9 out of 21 is the same as 3/7. But we want the 21 on the bottom. So then that way we can add across the top. Common denominator stays common. Everybody say common. Don't know if you said it, but I hope you did. Common because it stays the same all the way. Add across the top. Are they both even? Nope. So they don't end in 2, 4, 6, 8, or 0. Try 3. Don't forget 3. 3 does go into 21. 3 cannot go into 16. So then we're going to keep trying some odds. Does 5 work for both of them? No. 7 works for 21. Not for 16. Not 9. So you guys have mowed 16 21st. 16 out of 21 pieces or parts of, or that's the fraction, 6/21 of the lawn. So again, working our way through. You can see our scale. Working on this, adding positive fractions, having some mixed numbers in there as well. Needing to be able to demonstrate those in word problems. And again, you can see all the things we'll be working on through here, some vocabulary and things we have to do. But today, just focusing on adding positive fractions and mixed numbers.